Hello, welcome to mathematics course. Mathematics course is divided into 10 modules, and this is the first module and is on measurement. Measurement is the foundation of understanding the world. Whether we quantify length, mass, time, temperature, or digital signals. Measurement is what turns observation into actionable information. So this module introduces core concepts of measurement, unit systems, conversions, and the practical role measurements play across business, sports, agriculture, science, and technology. Now, measurement simply means assigning numbers to physical properties so we can compare, monitor change, and make decisions. So, accurate measurement reduces uncertainty and supports repeated outcomes. So the key features or attributes of measurement is accuracy. Accuracy means closeness to the true value. Precision, that is, it also means repeatability. Resolution, okay, and uncertainty. Now, the International System of Units (SI) provides consistent base units like fundamental units like meter, kilogram, seconds, ampere, Kelvin, mole, candela, ensuring global communication. All right. So these units can be converted from one form to another. So converting between units is a practical skill. It preserves meaning across contexts and prevents costly mistakes. Common conversion can include metric, that is imperial length, meters to feet, mass, that is kilograms to pounds. If for volume, it can be liter to gallons, or between different volume measures, and time from minute to hours or minute to second. So use conversion factors, dimensional analysis, and significant figures to maintain precision. Now, in dimensional analysis, multiply by conversion factors that equal 1, e.g. 1 inch is equal to 2.54 centimeter. It's like saying 60 seconds make 1 minute. So if 60 seconds make 1 minute, you now begin to think, okay, if 60 seconds make 1 minute, how many seconds will make 20 minutes? You now do that by multiplying 20 times 60. So carry units through calculation to catch errors early. For instance, 1 meter is equal to 3.28084 feet. So if 1 meter is equal to 3.28084 feet, if you have 10 meter, it will now be 10 times 3.28084. The same to volume, right? So if 1000 cm cube is equal to 1 dm cube, that means if you have 3000, what will it be? It will be 3 dm cube. So that is it. So measurement is important in every sphere of life. Measurement is important in every sphere of life. Like what we just did, this little example, you'll find more in your general course in the module. A lot of calculations and conversions. But let's go further to look at the importance of measurement. Why is measurement important? It's important in different spheres. For instance, in business measurement converts operations into strategic intelligence. It's what we call financial KPIs, customer metrics, and operational indicators. All those guides investment, pricing, staffing, and risk management. So reliable metrics in business enables forecasting, benchmarking, and continuous improvement. Now, there are three major areas of that businesses make use of measurement. We have financial metrics. This one concerns revenue, gross margin, customer acquisition cost, lifetime value, measurement precision. Okay. So then we'll talk about operational metrics. This one talk about the defect rates, one-time delivery, cycle time, So while we have customer marketing metrics, so I'm talk about conversion rate, net promoter score, you know. So consistent measurement designs enable valid A/B testing and growth experiments. Let's also look at the importance of measurement in sports. In sports, measurement transforms training and tactics. Biomechanics, wearable sensors, and performance analytics quantify speed, power, fatigue, and workload to reduce injury and maximize output. You know, coaches translate objective metrics into individualized training plans. So in sports, measurement is important. Measurement of scores, measurement of number of passes, different kind of measurement. You know, so heart rate variability can be measured. That is the physiological metrics that is in sport. Then motion capture and video analysis, and the angle with which the ball is gotten. So all those are still part of measurement in sports. What of agriculture? Is it left out? No. Modern agriculture relies on precise measurement for resource optimization. Talk about soil moisture, nutrient levels, and yield mapping. All these enable variable rate inputs, conserving water and fertilizer while boosting productivity, data-driven decisions, increase sustainability and profitability. So, in the measurement in agriculture includes soil and water monitoring, remote sensing, and yield mapping. Now, what of science? Scientific progress depends on reproducible, precise measurement. So, science do a lot with measurement, from particle physics to molecular biology, units, standardized units, calibrated instruments, and quantified uncertainty underpin hypothesis testing, modeling, and peer validation. So, there is a lot of data measurement in physics, in general science. There's a lot of measurement and conversion from one unit to another. All right, let's look at measurement in technology. Technology is not also left out. Technology depends on accurate measurement, you know, that scales from nanometers to cloud level latency. So, in tolerances in manufacturing, signal integrity tests and performance benchmarks determine product reliability and user experience. So, there's what we call software metrics, where technologies talk about latency and throughput. So, they also measure network and telemetry to provide feedback loops for optimization, scaling, and reliability. Now, uh, integrating GPS heart rate and force plate data, tailored load management, decreasing injury incident by while improving sprint power. All these are common applications of measurement to life. Or variable rate fertilization, I've mentioned this before, guided by soil sensors, boosted average yield by 12% and cut fertilizer use by 20%, improving margin and environmental sustainability. What of standardized calibration procedures and uncertainty budgets, which enable cross-lab replication? This accelerates peer review publication and adoption, you see. So, measurement is very important in every sphere of life. So, you wonder if in your life as a learner you have carry out different kind of measurements before and for different purposes. So, measurement is important. Measurement is what translates observation into knowledge and action. Across business, sport, agriculture, science, and technology, we have seen that a precise and consistent measurement reduces risk, enables optimization, and fuels innovation. So we have to master conversion. We have to understand uncertainty and choose the right metric. Doing so multiplies your ability to make informed, repeated decisions that lead to reward improvement. So SI units And conversion proficiencies are essential for clear communication and interoperability. So what you should do is that you have to make yourself conversant with SI units, fundamental units, length, mass, time, so that you study the measurements and how they are being converted from one form to another. So all these are explicitly explained in your model. So practice conversions and design measurement. Thank you for listening.